All right. So now that we've simplified this length here, we can go ahead and write it here, and then we can add up all of our sides because we're doing perimeter. Okay, so I like to go ahead and write in all the sides so that I can visually see what's happening. And when we add, we combine like terms. Okay, so we have to look at all of our x's. We have an x here and an x here. We can't add the x squareds to them because those are different terms. Only the x, the regular x's. So we have a total of two x's. Okay. We have some x squareds. We have 2x squared. I'm going to put at the beginning. I should have done that one first because I like to start out with the most exponents and then go down to the least. And then my last would be just the regular numbers. We have a 25, a 25, a 4, and a 4. So that's going to give me 58 when you add those together. So this is the answer. The perimeter of this rectangle would be 2x squared plus 2x plus 58. You're just adding all the sides. It's perimeter. Number 2. It says the terms 2x to the third, 4x to the sixth, 8x to the ninth, 16x to the 12th represent a sequence of numbers in a code. By what number is each term being multiplied to find the next term? So, okay, this is kind of from another unit. What I want you to do here is look at those numbers that they give you. What do you see? Is there a pattern between one term to the next? The number is increasing by 2. Okay. What else do you see? Okay. The exponent is doing what? It's double. It's not by 3. It's squaring, right? It's squaring. Nope, by 2. Wait. It's adding by 3. Yes, right. See, I'm glad that y'all are looking at this too. So it's adding by 3. All right, so we have the number is multiplying by 2 and the exponent is adding by 3. So I'm going to write that down just so you see that the number is increasing times 2. I'm just going to write these notes here. And the exponent is adding by 3. Okay, those are the notes that we have. That's what we have analyzed here. So how we are going to write that and how you'll see it tomorrow, it's going to be that n thing. I don't know if y'all remember that with the n, the number, or whatever. So this is kind of a review. Let me see exactly how they put it. I'm looking at this key here so that I don't tell you the wrong way to write it. If there's like a way that they want the number before the letter or something. So hold on to pull it up. Okay. Okay, so it is increasing by 2, and all we have to do is say it's 2x to the third, okay? The number is increasing by 2x to the third, which is what we just said here. The number is increasing by 2, the exponent is by 3. I'm sorry, I had it zoomed in. So that's all you need to write, okay? So that was it wasn't that difficult. Yeah. All right, let's go to number 3. On number 3, it says, study the table below. Based on the pattern of the table, a with the exponent to another power is equal to which of the following? Okay, so what is happening here? We have when it's a1 to the second power, it's a to the second. When it's a2 to the 3, it's a to the 6. So what's happening? They're multiplying the exponents. Okay, so it's equal to what? What?
It's not, it's just saying like if you change your name.
Yeah, any number where you have b as your first exponent inside the parentheses and c as the second one, what would it be on this side? And we figured out the pattern was that they're just multiplying the two exponents. So that's what B, answer choice B is. You're multiplying the two exponents. So it's B. Okay, number 4. A wall mosaic is being designed. The tiles for the wall make a rectangular grid. Okay, here's my rectangle consisting of M3 to the 3 rows. So there's going to be 3 rows. 1, 2, 3. And 5 columns. 1, 2, 3, 4, 5. Those aren't very equal, but whatever. So which expression shows the number of tiles on the wall? Well, how many tiles total would that be? Yes. Okay. So we know the total tiles is 15. Okay. But we have to show an expression. So it would be m to the 3rd times m to the 5. Okay. And so that's how you would kind of write it on here. So technically, if we wanted to solve this, we could say it's m to the 8th because when you multiply exponents, it's m to the 8th. But you just need to know that that's what you're doing is you're multiplying the rows times the columns. I mean, you guys know that, but you've just never seen it expressed like that. Okay, number 5. A location of a wall mural is being marked off as shown below. Okay, here's where we've been doing, this is the stuff we've been doing lately. Yeah, I mean, this whole thing, they want you to write an expression. M to the 3rd times m to the 5. Okay. But I just went ahead and put m to the 8th because we know that's how you do exponents when you multiply them, you add them. Okay, number 5. This is a wall mural, and they have the length and the width. They want to know how would you get the area? You don't have to answer the area, but just how would you get it? Which expression? What do you do? Yeah, you got to multiply them because we know area equals length times width, right? So to get the area, you would just multiply them. 2x plus 1 times 3x plus 5. Okay, so we don't have to answer this one, but how would you answer this one? What would you do? Yes, thank you. I just want to make sure you guys see that's 2 binomials that you're multiplying. You would FOIL here if you were going to answer that. Okay, all right, so we can go on to the next page. Number 6, page 2. Actually, it says number 5 again. Great. We're doing another 5. Somebody got off on their numbering. It's fine. Okay. I'm going to tell you right now, there is a question like this on the test on Friday. And it's not exactly these same shapes, but basically you'll see like level 1, there's one square, and then in level 2 it'll say the same thing. It's the same thing, but there's different numbers, okay? Different numbers of tiles, squares. So if we know when n equals 1, when it's the first level or step, there's 1 tile. When n equals 2 on step 2, how many tiles are there? How many tiles are here? Step 2. 4. 4 tiles. When the step or an n or the number 3, step number 3, there are how many tiles? 9 tiles. Does anybody see a pattern? 1 to 1, 2 to 4, 3 to 9. It's squaring. Do you see that? 1 squared is 1. 2 squared is 4. So what is step 4? How many tiles are there going to be? 16 tiles. Okay. So what's happening here is, which is the expression that's happening? What's happening? J. Good. N squared. That's the pattern. So you could say, well, what is it going to, how many tiles are there going to be on step 10? Well, you would say 10 squared, 100. There's going to be 100 tiles. So it's always going to be, it would always be that rule. Okay, number 6. What is equivalent to a to the negative 3? Okay, this is going back to exponents. Do y'all remember what we do with negative exponents? For a negative exponent, we put it under 1, right? So we would say 1 over a to the 3rd. So what's the answer? D. Okay. Number 7. A box has a length represented by x plus 4 and a width, which is x plus 1. Oh, it's a box. Dang it. I'm terrible at drawing 3D shapes. Are y'all good at this? Because I'm not. Okay, so this is x plus 1. That's the width. And then the height, this part is 3. Fabulous. Okay, so once to figure out the volume. Okay, what are we going to have to do here? What is volume first? Length times width times, yes, it's a 3-dimensional. Whoops. L times width times height. Okay. So what are you going to end up doing to get the volume? Oh, yeah. Okay. And it doesn't say that we have to do that. It just wants the expression. It doesn't matter what order you put them in. Okay. Length times width times height. I actually just put mine in width times length times height, whatever. Okay. When you multiply, it doesn't matter how you do it. You're all going to get the same answer. How would you go about solving this? Okay, but what steps would you take? You can't put an x in a calculator and know what the value of x is. That's exactly what I would do, Emily. Good. So I would FOIL this first. And then you would take your answer and multiply by 3. You would distribute the answer, like you would distribute a 3 into the answer, multiply the whole answer by 3. Okay, good. On number 8, says the area of a rectangle is represented by, yeah, I just said write an expression. So we're not solving it, but I do want you to see how you would solve it. That's important because I want you to know you could solve it. It's not something that's not doable. Okay, so the area is, it says the area is this. I'm going to write that 8x to the 3rd times 2x to the 5th. Okay, so they're giving us the area. They're also giving us the width, 4x to the 6th. Okay, so how can we find the length? What expression? Okay, so what you would do first is you would multiply to get the area. And the reason I say that is because this is not simplified. Like you could fix this. And in fact, I'm going to do that because I want to see like the final expression, what the final expression would be. So you would say 8 times 2 is 16. And then what do you do with your exponents when you multiply them? Add them. Okay. So you would get, this is your area. No. 16 x to the 8th. And then how are you going to get the length from that? Divide. You're going to divide that by the width. And so this isn't that difficult. We could do it. So you would say 16 divided by 4 is 4. And then what would you do with your exponents? Yep. So this is the answer. Okay, are we doing all right so far? Okay. Number 9. Oh man, look at them pulling in some oldies. Some oldies. I don't know if y'all would call these goodies. So. But we can do this. All right, so simplify this. It says write the simplified form. Well, it just means to answer it. What do you do with your numbers? Your regular numbers. Just divide those like normal. 10 divided by 5 is 2. And then what do you do with your exponents? Yep. So you have a 3 and then a 1 on the bottom for the x's. So that's 2. 8 minus 4 would be 4. Y to the 4th. And z would be z to the 1st. Answer. You could put a 1. Yeah, that's fine. Your test is going to be multiple choice. So there's not any short answers on this test or gridables or anything. All right. Says simplify the expression. Oh, yeah, this is some fun distributing. Okay. So let's just start at the very first. We're going to distribute this whole 3x to the third inside, multiply it by each thing inside this parentheses. All right, so we have 3 times, this is a 1 in front, so it's 3 x to the 4th, x to the 7th, because you're adding your exponents, plus, and then 3x to the 3rd times 1 is just 3x to the 3rd. Here you have x squared times x, so you're adding your exponents, that's just going to be x to the 3rd, plus x to the 3rd, and then x to the 2nd times 4 is 4x to the 2nd. Okay, and then this is the only part where it gets tricky. I'm going to switch my color because this is subtraction. Do y'all remember what we do when we have subtraction? You change all the signs. You change the sign there to plus, and you change all the things in the inside to negative, or the opposite. So it's going to be plus a negative 1x squared, and then minus 5, or plus a negative 5. Okay. So now we just combine like terms to answer. Do we have any more x to the 7th? I don't see any. X to the 7th. Okay, I'm done with that one. But we have 2 that are x to the 3rd terms. We can combine those. We have a 3 and a 1. So that's going to give me a total of 4x to the 3rds. We're adding here. We're not multiplying. We have a 4x squared and a negative 1x squared. So that's going to give me a 3x squared when I add those together. And then just minus 5. And that's how you write the answer. Just go through your steps. Just simplify it one step at a time. Ooh, 14 is my fave. Y'all know what 14 is? 1. 1. That's it. Anything to the 0 power is 1. Okay, I realized I wasn't going in order. Do y'all want to just do 15 and 16? Okay. I just don't, some of y'all might be like OCD about going in order. So, all right. So on 15, what we're going to have to do first before we can divide is we have to kind of fix the top and the bottom. So what's going on here? This is an equal sign, by the way. That's not a 3. So here, all this is to the 3rd. So 3 to the 3rd, 3 times 3 times 3 is 27. And then, yes, power to power, we multiply. X to the what? 18. Good. And then this is just 3x to the 9th. And then we can simplify that even more. 27 divided by 3 is 9. And then x to the what? 9. You subtract. Okay, good. All right, 16, some good old factoring. I'm going to actually take this one out, and I'm going to change this, okay, this problem. I don't, there's not going to be one on the test that has a number in front of your x squared term that you can't FOIL to solve, okay? So I don't want to overwhelm y'all with that today. X squared plus, or no, minus 4x minus 32. Okay, I think I did this right. I should do that in my head. So what would you do first to factor this? We have to figure out the factors of what first? 32. Okay, so the factors of 32, 1 and 32, 1 times 32, 2 times 16, 4 times what? Yeah, that's it. So it's a negative 32 here. So one of these numbers has to be negative in each pair. And also you have to think, added together, how could it equal a negative 4? Yes. So look at this pair right here. If you had a positive 4 and multiplied that times a negative 8, you would get negative 32, which is what we're trying to get on the end there. It's a factor of negative 32. And then if you had a positive 4 plus a negative 8, you would get a negative 4, which is what we're trying to get in the middle. So your factors are 4 and negative 8. So what you do is how you write it is you say x plus 4, x minus 8. Okay. All right. So are we ready to go to number 11 at the top? Number 11. Victor is asked by his teacher to write an expression that will always produce an odd integer. Which of the following will always produce an odd integer for any given integer g? What? An integer is a number. So an integer is another word for a number. So which of these expressions, any number you put in for g, if you followed the expression, you would always get an odd number. Like, let's just do, it's what? So it's b, and here's why, okay? Let's just pick any number. Desiree, tell me any number from, it doesn't matter. I mean, what, any number. 12, okay? So if my number is 12, just say, this is just an example. Let's go through a 12 plus 1, that would be 13. That would be an odd integer. But what if my number was 11? 11 plus 1 would give me an even integer. It wouldn't always work, so it's not A. Okay. B, if I had 12, I could say 2 times 12 is 24, minus 1 is 23. And then that works. But I could also say, if my number was 11, I could say 2 times 11 is 22, minus 1 is 21. So that's always going to work because you're doubling something, which gives you an even number, and then subtracting one, which would give you an odd. So that's why I wanted to show you why B is the only answer. Okay. D would always give you an even number, and then C that it's not. It could be even or odd. All right, number 12. If y equals x to the -3, what is equivalent to x to the 18? Okay, so how would you get x? How could you get x to the 18 if you start with x to the -3? Huh? So this is a weird way to write it, okay? But how could you take x to the -3 and then make it go to x to the 18? -6, yes. Okay. Multiply it by -6. So what is the answer here? G. Yeah, that one's weird. Just the way it was. You kind of have to phrase it differently. Okay, number 13. Which equation is not, ooh, this is a not one. Those are always tricky. Which is not the equivalent formula for a total surface area of a cone? Okay, this is dumb. You get these formulas. The surface area of a cone is this. So you would have this written down, okay, on your paper, or I would give this to you. There's not a question like this on the test. So this is the surface area of a cone. That's a formula. Yeah, the pi times the radius squared plus the pi times the radius times the length. Huh? Oh, they did? Oh, that's great. Yes, thank you. Okay, so what would be is not the equivalent. So which of these, there are 3 of these that are the same thing as the formula for the area of a cone, but one of them is not. So which one is not? Well, this one is definitely the same. It's just you're switching this and this. Okay, so it's not that one. Let's look at D. You have pi and an r. If you were to multiply this out, you'd get pi r l plus pi r squared. So that's the same thing. You see that? Okay. If you were to multiply out C, you would get pi RL plus pi R squared. So what's the answer? A. Okay. A. Okay, 17. We're going to cross out the one they give you. And we're going to skip that and go to 17 on the back. So we're going to end with some factor practice. Yay. So again, you look at this last digit, 24, and you figure out what is a factor pair of 24, or negative 24 actually, that when added together would equal a -2. So you have to think in your head, what are the factors of 24? 1 and 24, 2 and 12, what? 3 and 8, 4 and 6. So it looks like 4 and 6 would probably be the best bet here. So which one would need to be negative? 6. Because -6 plus a +4 is going to give you a -2. So you have a -6, x minus 6, and x plus 4. Remember, you can FOIL these out and get back to there. I know I'm going fast, but I'm trying to finish this before the announcements come on. Ooh, 18 is a lot friendlier because they're both positive. There's no negatives that you have to mess around with. So factors of 14, that would equal, 48, that would equal 14. Let's see, 2 and 24, no. 3, is 48 divided by 3 is 16, and is 8 and 6. It is 8 and 6, yes. So 8 times 6, right, is 48, and 8 plus 6 is 14. Check and check. So we have x plus 8, x plus 6. Way to go. Good job. Okay, y'all remember what 19 is? Yep, difference of squares. So draw your square, your boxes, your squares. X squared minus 100. You have x times x equals x squared. Negative 10 and a positive 10 equal a negative 100. So these are your pairs here. X plus 10, x minus 10. Answer. 20. On 20, there's a GCF that you need to take out first. What is the GCF? 5 and an x squared. Good. So if you take out a 5 and an x squared, remember you have to divide by 5x, both by 5x squared. You end up getting a 3. 15 divided by 5 is 3. And then you get an x minus 1. So your answer, this is not a difference of squares here. You can't factor this anymore. So your answer is just this. 5x squared times 3x minus 1. On number 20, this is good old-fashioned factoring. Ooh, we have to equal a negative 9 in the middle. So, but a positive 20 when multiplied. So we could do what? Yeah, they both have to be negative. Negative 4 and a negative 5. Good. Multiplied together, that equals a positive 20. And added together, that is a negative 9. Okay. Okay. So we have x minus 4 and x minus 5. Okay. Gosh. Difference of squares down here, because both of these are squared terms. We're going to finish quickly. I know they're loud. It's okay. So what's going to equal 4x squared? 2x and a 2x. And then 25, square root of 25 is a negative 5 and a positive 5. Yeah. So 2x minus 5, 2x plus 5. Answer. And on the last one, this is supposed to be 20. Yeah. Okay. On the last one, you have 6x squared y minus 3xy. What you need to do there is just, it's a GCF. Okay. What are they going to have in common? 3x and a y. So you're going to pull that out. Okay. So you'll end up with a 2 and an x minus 1. Answer. Bam. Okay, guys. So tomorrow we're going to be doing a review game. It's not going to be using the problems on this review. It's going to be doing some more review problems. Oh, yeah. Okay, the exit ticket. Let's pick. Which one? Pick one of these problems. I don't care which one you pick. I want you to pick it and answer it right now. Pick one and answer it. And on your way out, you're going to give it to me. What, you still have 6 minutes, by the way. What, oh, also get this review signed for 5 points. I meant to tell you that.